In this lecture, we will solve the next multiple choice question. In this question, we are having signal xt, and signal xt is a positive rectangular pulse starting from t equal to -1 to +1 with unit height as shown in the figure. In this figure, you can see the waveform of signal xt. It is equal to 1 from -1 to +1, and for other values of time t, it is equal to 0. So we are having a rectangular function as our time domain signal xt, and xt is having the Fourier transform equal to x omega, and we need to find the value of this integral. The integral is equal to integration -infinity to +infinity mod x omega whole square d omega, and there are 4 options, and we have taken this question from GATE 2010 exam. So let's move to the solution of this problem. Let's say the integral here is represented by capital I. It is equal to integration -infinity to infinity mod x omega whole square d omega. And we know the Fourier transform of a rectangular function is equal to sampling function. But there is no need to calculate the Fourier transform of this signal. We can have the answer directly. I will multiply 2 pi in numerator and 2 pi in denominator on the right hand side. So we have 2 pi divided by 2 pi integration -infinity to infinity mod x omega whole square d omega, and we know 1 over 2 pi integration -infinity to infinity mod x omega whole square d omega is equal to the total energy of signal xt. So here, if we include this 2 pi in denominator with the integral, then we can say that it is equal to the total energy of signal xt. So our integration I is equal to 2 pi multiplied to total energy of signal xt. And we have seen in the lectures of energy signals, the total energy is equal to the area under the curve mod xt square. So in place of total energy of xt, we can write area under mod xt square, and we can calculate the area under mod xt square. We are having the waveform of signal xt, and from here it is clear that xt will be same as mod xt. So area of mod xt will be same as area of xt. We can calculate this area. We are having a rectangle. The height is equal to 1 and the width is equal to 2. So area is equal to 2. In this way, we are getting I equal to 2 pi multiplied to 2, or we can say it is equal to 4 pi. So option D is the correct option. There was no need to calculate the Fourier transform x omega. You can have the answer directly if you know the formula of total energy, which we got in the Parseval's energy theorem, and the basic understanding of energy signals. So this is all for this lecture. See you in the next one.